Do liquid and gases also exert pressure like solids?
A wooden block kept on a table exerts a force on it, and we know that the wooden block is a solid substance. What about liquids? We know that liquids are kept in containers. Do liquids or fluids exert pressure? Yes, they do. They exert pressure on the base and the walls of the container in which they are enclosed. The pressure on the base will be downwards, and on the walls the pressure will be sidewards. We can also derive something interesting if we look at the fluid in terms of layers. Say there's water kept in a plastic container. Let's divide the fluid into 5 equal parts. You can see that the second layer of water is holding the weight of the first layer. Similarly, the third layer is holding the weight of the first as well as the second layer. And the fourth layer is holding the weight of the top 3 layers, and so on and so forth. So clearly, the pressure at the bottommost layer is the maximum. There's even a way you can find this out. Near the topmost layer, make a little hole at the side. You'll see that the water flows out from that hole like this. It doesn't roll along the walls, it flows out at an angle. Now let's make a second hole near the layer under it. You'll see that the water flows out at a wider angle as compared to the earlier case. We continue to make holes in the wall, and we'll notice that the water literally squirts out. This proves that the pressure at the bottom is much more than the pressure at the topmost layer.
Do you know what happens when you blow air into a balloon? It exerts pressure in all directions. That's why the balloon increases in size and shows equal enlargement in all directions. The same is also true for the liquid. It also exerts equal pressure in all directions. When a plastic disc submerged in water, it does not fall down. It is continuously pressed against the glass pipe by the pressure of the water. This implies that the water exerts pressure in all directions. Air and our atmosphere. We know that there is air all around us. This envelope of air around the earth is known as atmosphere. Actually, air has weight and therefore exerts pressure. The pressure of the air upon the surface of the earth is called atmospheric pressure. Note that atmospheric pressure is decreasing as we go up and up. On an average, the weight of air on our head is 1 kilogram per centimeter square. Daily life experience of atmospheric pressure. We know that when we use a straw for drinking water, for taking a sip from the bottle, and when we take medicine from bottle to the syringe, and also when we refill our pen using ink, this all atmospheric pressure has a great role in these things. Do you know what happens when you sip the cold drink? The air pressure inside the straw is reduced and the air pressure on the surface of the drink pushes the drink up into the straw to reach our mouth. In case of a syringe, the doctor dips its nozzle into the liquid and pulls the piston, thereby lowering the air pressure inside the syringe. And in another example of ink-filled fountain pens that have rubber tubing, the rubber tube is pressed to push out the air from it, thus reducing air pressure inside the tube.
Summary. Let us summarize what we have learned. Force is a push or a pull resulting in motion of a body. Force can change the shape of an object, move an object from the position of rest, change the direction of a body in motion, and change the speed of the moving object. There are 2 kinds of force: contact force and non-contact force. Muscular force and force of friction are the examples of contact forces. Gravitational force Electrostatic force and magnetic force are the examples of non-contact forces. Force per unit area is known as pressure. Pressure from solids is due to their weight and acts downward, but in the case of liquids and gases, the pressure exerted by them is downward, sideways and upward also, that means in all directions. The envelope of air around the earth is known as atmosphere. The pressure of the air upon the surface of the earth is called atmospheric pressure.
And it's part of the Year 9 science curriculum. Is what we're going to do is we're heating up a little bit of water in the bottom, and as we heat the water up, it changes phase from liquid to gas, and that gas fills that space, and all of the inside gets really hot. And then what we're going to do is we're going to switch the gas off, and we're going to close the lid, and we're going to put the hose pipe on. And what should happen is that because the volume expanded when it was hot, and then it changes back from water vapor to water liquid, it's going to create a whole lot of, it needs less space, and it won't be able to suck air in because the lid is going to be on, and then it's going to collapse in. So I think we're pretty close to being there. So maybe Mr. Hodgson and Mr. Briscoe, we can just take the gas out.
Hi, Miss Hatcher.
Tell me when to start. You guys may as well start when he gets the hose out. Stand your ground, friend.
Yeah.